Welcome to the Banker Lamp. Please enjoy the video.
You start by confirming the GPU, driver, and sufficient RAM so tasks actually fit. This prevents wasted time. Once done, install the vendor SDK and CUDA/cuDNN matching your framework versions, then reboot to load drivers. Create or activate a virtual environment and install the GPU-enabled build of your framework so Python uses the card by default. Make sure to set device flags or environment variables now. This is the first actionable step that moves you from CPU to GPU execution. You now adapt code and data to the GPU, move tensors, models, and data loaders onto the device, and use non-blocking transfers for overlap. Once data lives on the GPU, increase batch sizes to use memory efficiently but avoid out-of-memory errors. Enable mixed precision when supported to accelerate math and reduce bandwidth. This often yields large speedups. Finally, run the profiler to see kernel time and memory usage so you can iterate. Profiling explains why performance behaves the way it does. You finish by executing complete runs and monitoring utilization, temperatures, and clocks to ensure stable performance. This confirms the speed gains are real. If you hit out of memory, reduce batch size, use gradient accumulation, or enable memory pinning and mixed precision to recover. When things still go wrong, compare CPU versus GPU timings, check driver logs, and validate CUDA versions. Often a mismatch causes silent falls back to CPU. This single troubleshooting step will usually reveal the root cause and get you back.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.